Alright, so for your 8-2 practice, you're going to solve these the same way we did the other day, where you're going to plot your vertex. Negative 5, 0, coming from those numbers. And your a value is 2, so you're going to go up 2 over 1. Draw your square root. You don't need the other side because it's a square root. So that is f of x. For the inverse, we're going to reverse these points. So instead of it being negative 5, 0, it's 0, negative 5, and negative 4, 2. So 2, negative 4. So 0, negative 5, and 2, negative 4. So your inverse goes like that. Is the inverse a function? Yes. And then the domain for f, you're going left all the way to negative 5, right to infinity, down to 0, up to infinity, and then for the inverse, they just flip. Alright, let's do this cube one. 2 and 3 are pretty much the same thing. Alright, for the cube one, your vertex is here at the origin 0, 0. Your a value is 1, so up 1 over 1. Alright, for your inverse, your points look the same, but your graph, remember, is being reflected across this line. So instead of it going this way, it's going to be reflected and go this way, and then instead of it going this way, it's going to be reflected and go this way. So I know it kind of looks weird, but yes, it's still a function, and the domain for all of the x's, or I mean the cubes and the cube roots, is negative infinity to infinity, and so the domain of the inverse will be the same way. Alright. Finding the inverse algebraically. Switch the x and the y. And then we're going to solve for y. So 2 over 3 equals y squared. Square root. And so your inverse is plus or minus square root x plus 2 over 3. And no, it's not a function because of the plus minus sign. Alright, 6 is the same way. Let's jump over to 7. Switch the x and the y. Square both sides to get rid of the root. X squared equals 5y minus 3. And now we can solve for y like usual. Add 3. X squared plus 3 equals 5y. Divide by 5. And so your inverse is x squared plus 3 over 5. And yes, it's a function, specifically a quadratic one. Flipping it over on the back. And we'll do number 8. Switch the x and the y first. Ooh, it's 5. Alright, so I want to get rid of this 1/5 first before I square it because the 1/5 is on the outside. So I'm going to get rid of it by multiplying by 5. So the 5 and the 1/5 cancel. 5x equals the square root of y minus 1. Square. So make sure you square both of those guys. 25x squared equals y minus 1. Add 1, add 1. And so then your inverse is 25x squared plus 1. And yes, it's a function. Only time it's not going to be a function is if you get the plus minus sign. Okay. 11 through 13, we're just trying to prove whether they're inverses. So I'm going to put this guy into to this function. X squared plus 5 minus 5. That cancels. That cancels. And so I'm just left with x. Then I'm going to put my root function into my quadratic. So x minus 5 squared plus 5. That cancels. X minus 5 plus 5. Your 5's cancel. And you're left with x. So yes, they are functions. Alright, same thing over here. Put my fraction into the root. So first I have the square root of 3, x squared minus 7 over 3, plus 7. 3's cancel. X squared minus 7 plus 7. 7's cancel. Roots and square cancel. I'm just left with x. So that way works. Go the other way. Square root 3x plus 7 squared minus 7 over 3. Squared and the square cancel. 3x plus 7 minus 7 over 3. The 7's cancel. The 3's will cancel. You're left with x. So, yes, that one is also a function. Last one. Take that guy. Plug it in here. 2/3. 3/2 x squared plus 8. And then the minus 8. So this 2/3 is being multiplied by everything on the inside. So those guys cancel, and you're just left with x squared. 2/3 times 8, though, is going to be 16 over 3 minus 8. And those guys are not going to cancel. So it doesn't work.